Hello and welcome to my YouTube channel. Today I'll be solving last year's final year examination on applied electricity. That was, this is the examination for 2024-2025 academic year. So the questions that I'll be solving from question 90 to 120. This question covers chapter 1 to chapter 4, which we have just finished some 2 weeks ago. So I'll start from question 91. So question 91. The following are statements about Ohm's law, except one: current is directly proportional to the voltage supply. So that is true. It can be used to find the resistance of a conductor. That is 3. Then 2, increasing the voltage supply decreases the current flowing through the conductor. So you can see that the third one question, the second one here is wrong, right? So that will be the one that is, so the answer here will be B, right? Because if you are decreasing the voltage across the conductor, that the current tend to increase, right? Yes. If you are decreasing the voltage, the current flowing through the, if you increase the voltage supply, this should rather increase the current flowing through the conductor. 92. Millman's theory is only applicable to a specific kind of circuit diagram. So this one is true. So before you use Millman's theory, you make sure that it fits the kind of circuits before you can use the Millman's theorem to solve for the current passing through the load resistor. 93. The operation of a Wheatstone bridge is better explained with the help of Thevenin's theorem. So this one too is true, right? So we can use Thevenin's theorem to explain how the Wheatstone bridge operates. 94. The type of network topology depends on the kind of shape formed by the network resistors. So this is also true. So the answer here is D, right? 95. Resistance of a conductor is determined by using Ohm's law, yes, and 2, meaning I, and ammeter III, a Wheatstone bridge. So here we can use an Ohm's law and then a Wheatstone bridge to find the resistance of a conductor. So the answer here becomes C, meaning I and II only. Question 96. The following materials have high resistivities except, so which one? If you look at paper is an insulator, so it's supposed to have a high resistivity. The same for plastic and mica. They are all insulators, so their resistivity is supposed to be very high. Then we have D, which is aluminum. Aluminum is a conductor, so its resistivity will be very small. So the answer is D. A conductor having a large cross-sectional area will have a small resistance. How do I know this? Because we know that when it comes to the resistance, right? We know that resistance of a conductor is equals direct proportional to the length, right? And the inversely proportional to the cross-sectional area of the wire, of the conductor. Then we add the resistivity of the conductor. So if the cross-sectional area is very large, see that the resistance will be very small. In a household, 20 light bulbs of 40 watt each are used on average 35 hours each, while a flat iron of 300 watts is used on average 10 hours each. The unit cost of electricity is 80 Ghana pesos. Calculate the total energy use. So the total energy use will be the energy used by the what? The light bulbs plus that of what? The flat iron, right? That of the flat iron. So how do I find this? So we first get the energy used by the light bulbs, and that is going to be equals to, so we have 20 light bulbs. So then that means you multiply 20 by the energy of only one light bulb, which should be what? Energy is what? Power times time. So we have the power here is 40 times 40 times the time, which is said 5 hours, right? So this will give us, for the 20 light bulbs, what do I get? So here I'm going to get, answer will be, first we have 0 times, meaning 800 times what? 35. So we have 0 0. Okay. Then 38 times 35, we have here to be 40. 8 times 3, 24, plus 4, 28, right? So we have 28 watts, which will be 28 kilowatts. I mean, 28,000 watts, which will be 28 kilowatts. Kilowatt hours, right? So let me write this clear. Okay, so we have this. This is for the light bulb. Now, when it comes to the what? When it comes to the iron, the flat iron, we have what? 300 watts, and it uses on average 10 hours. So I have again an energy with what? Power, which is 300 watt times what? Time, which is 10 hours. So that will give us 3 kilowatt hours. So we add this, that will give us a total. So this plus this will be 31 kilowatt hours. So when you look at here, the answer is not there. So here, this was given as bonus. So I think here is supposed to be 31, but it was given as bonus. So here, 31 kilowatt hours. Now, question 99. So let me remove this. Okay. Now, let's go to question 99. What is the total cost of electricity of the household in question 98? So, cost of electricity, we know 1 kilowatt based on the question, 1 kilowatt hour. You have to pay 80 Ghana pesos. So, and we have spent 31 kilowatt hour of energy. So that will give us S. So if you cross multiply, you get here to be 31 times 80. And that will give us what do I get? 0, 8, 8, 8 times 3, 24. Okay. So you get 24. So you get the answer here will be equals to 24.8 Ghana cedis. So again, here the answer is not there. So this question was given as a bonus, right? So it was given as a bonus. Okay, so for the answer will somewhere be here, maybe be. A current of 4 amps transfer a charge of 3,600 coulombs. The time taken to transfer the charge is, so here we are giving the what? The So with this question, we are giving the charge, right? 3,600 coulombs. And then the current is what? Just 4 amps. So we know current is equal to charge over time. So we make time the subject so that I can charge over current. So time becomes equals to 3,600 over 4. So this will give us what? 9, right? So we have 900 seconds. So 900 seconds, you change that to minutes. What do I get? So I just have 900 divided by 60 seconds, right? That will give us 15. So the answer here is C. Now we go to the next question, which is the figure that we are giving here. Use Thevenin's theorem in figure 4 to answer question 101 and 102. What is the load resistor value that will dissipate the maximum power transfer? So when it comes to the maximum power transfer, we know that we should have this simple circuit, right? So we have a voltage should be in series with what? Source resistance. So I can write here Vs. Then we connect our load, right? So we connect our load resistor RL. Right. So I have to arrange this to resemble something of this nature, right? To resemble a simple circuit. And the way we do it is by using Thevenin's theorem. So here, when it comes to Thevenin's theorem, it's the same thing, but we just call this RTH and then VTH. So I have to get VTH in RTH, and my RTH will just be the same resistor, right? It's going to be the same resistance as the load resistance. That will give us the maximum power transfer. So let's get RTH from what? This circuit diagram, right? Getting RTH. Now, when it comes to RTH, remember first we have to remove our load so that we have our linear active circuit. So I have this to be 24 volts. Then I've removed the load resistor. Here is what? 8 ohms. And then this place is supposed to also be the resistor here, which is 2 ohms, right? So we have this. Now that I've removed this, then to get RTH, we know is that is the equivalent resistance when all independent sources are turned off. So I can see I have 24 volts here, which is a voltage source. So I have to turn it off. How do I turn it off? By just coming and remove it, right? We remove this. Then after that, we just connect a wire, right? So it's turned off. Now, the equivalent resistance here, which is going to be our RTH. So that will just be what this. You can see 2 ohms and 8 ohms are connected in parallel because they are connected end to end, right? So I have 2 times 8 over 2 plus 8. So that will give me 1.6 ohms. So the answer here is A. Calculate the maximum power dissipated by the load resistor. So when it comes to the maximum power, we can just use the formula straightforward, which is maximum power be equals to, remember, Vs square over 4Rs. Okay. And this is based on our circuit diagram here. Our Vs, which is a voltage source, is our VTH. So we have VTH square over 4 times RTH. So I have to get, I know RTH, what? Trying to get the open circuit voltage. So let's get that one. So how do I get VTH? So here, after we've opened the circuit, so this terminal here is A, right? So I have terminal A is here and then B. So here becomes our VTH, which is the same as the open circuit voltage, which is the same as the voltage across terminal A and B. And when we look, you see that would just be what? The open circuit would just open circuit voltage would just be the voltage across 8 ohms. So VTH becomes equals to the voltage across the 8 ohms resistor, and that simply is going to be equals to. And when you look here, if there's current, so now we have to bring back our voltage. Right. How to bring back this. Our 2 ohms is here, right? I have our 2 ohms. So we have 24 volts. So when we look here, the voltage across the 8 ohms will just be, again, imagine there is current, right? I have current here, I. So you see here, this is an open circuit, so no current will pass here. So all the current will pass through this and then come to this, right? So 8 ohms and 2 ohms are in series. So hence, to find the voltage across 8 ohms, it will just be what? 8 resistance over the sum of the resistors in series. So that is 8 and then 2. So 2 plus 8 times the voltage, total voltage here, which is what? 24. And that will give us, right? And that is going to give me the answer to be 19.2 volts. So we have this formula. So when you come, then you replace. So the maximum power dissipated by the load resistor will be equals to 19.2 square over 4 times 1.6, and that will give us 57.6 watts. So that will be C. The internal resistance of a current source can be minimized by, so when it comes to a current source, right, you minimize the internal current. The internal resistance of a current source can be minimized by what? Decreasing the load resistor, which we did. So remember here, if you want to get the you want to make sure the current passing through the load resistor is the same as the current. So what do? You make sure that the current, in that case, you should choose what? The load resistor to be a very small value. So me here decreasing the load resistance. The Thevenin's equivalent resistance is calculated by turning off all independent sources. So the answer is D, turn off all independent sources. Norton's equivalent resistance is different from Thevenin's equivalent resistance. That's false. Remember, RTH is equals to what? Rn. So this is false. In using Norton's theorem, the load resistor is short circuited, right? Remember, when you are using Norton's theorem, you short circuit the load resistor. Now, question 107. Find the current that flows through 10 ohms resistor in figure 5. So this figure 5, we are interested in this current that is passed through this 10 ohms. That you can see. You can see here the current here that we have is the one that is passing through the 10 ohms. And that current is what? The current source in figure 9. So here should be figure 5. Okay, it's a mistake here. In figure 5 is 8 ohms. So this place is 8 ohms. And if you see the current that is passing through the 10 ohms here is the current source here, which is 8 ohms. So the answer is 8. Determine the voltage across 5 ohms resistor, right? So to find the voltage across the 5 ohms resistor, which is here, I'm going to use nodal analysis method. So what that means that I'll first indicate the current. So let's say I'll indicate the current here, right? So let's say this is I1. Now indicate here as I2, then I have I3 leaving, right? So you can see that if I apply Kirchhoff current law to, let's say, node A here, that becomes I1 plus I2 equals what? I3. Now let's express the current in terms of what? The voltage and the resistor. So when it comes to I1, you can see I1, the same current I1 here. We come here, yes, I3, I1, right? And then we already have here, which is I2. So I2 here is just 8 ohms, right? The 8 ohms here. Okay. Now that we know this, so let's find I1. I1 here will be equals to, again, the same current is, but I1 is battery 4 ohms and what 2 ohms. So they are in series. So I can have here. And then so the current here originate from the 5 ohms. So I'll take the higher voltage, which is 5, where the current originates, minus the voltage at node A. So I'll label here VA. Then over 4 ohms and 2 ohms, they are in series. So I have 4 plus 2. Then plus we come to I2. I2 here, you can see the current there is just 8 watt. So plus 8. Then when you come to I3, again, the current is coming from what? Node A. So that what? VA. Minus here, this node, we ground that node. So that will be VB. VB, when it's grounded, the voltage is 0. So I'll just have what? VA minus 0, which is VA over 5. So I have this. So to solve this, I can multiply. So here will give me 6. So let me just come here and simplify this. So this will be 6. I can multiply those by 30. So that will get, here will be what? 30 times 6. So that will be 30 divided by, that will be 5. So here will be 25 minus 5 VA plus 30 times what? 80. 30 times 8. So that will be what? 0. 3 times 8, 24. So here will be what? Here multiply by 30. So here will be 6 VA. So with this, we send the 5 VA across the course and become positive. So I can write VA will be equals to 25 plus this. That will be what? 265 over 11. And VA, when you do that, you get what? The answer to be equals to 24 point. You get the answer to be 24.091. Okay. I'll give you this volts. Now we go to the next one. Solve the power dissipated by the 4 ohms resistor. So to get the power dissipated by the 4 ohms resistor, which is here, right? So first, let me get the current, right? What will be the current? We know I1 is equals to what? VA minus V over 6. So I can write here I1, which is the current passing through the 4 ohms. So 5 minus 24.091 divided by 6. So what do I get for this? Okay, so when you do this, right, that will give us the answer for the current. Give us the answer for the current. And then once I have the current, the power will be equals to what? Current square I 1 times what? Resistance, which is 4 ohms. So the whole of this will give us, so you come and replace the whole of this, 5 minus 24.9 0.091 over 6, then square of that times what? Times 4. That is going to give us 40, right? We get this 40.496. Okay. Ohm's law says that current through a resistor is directly proportional to the voltage supply in a closed circuit. Right, so this is true. Current through is directly proportional to voltage supply. So we have A. Question 111. Use figure 6 to answer question 111 to 113. So when it comes to 111, we are asked to calculate the overall equivalent resistance in figure 6. So we can see here when it comes to this figure, can see that 4 ohms and 9 ohms are connected in series. So I can just come here. So that will be what? 4 plus 9, 13 ohms. Then when you come to 2 ohms and 6 ohms, they are also connected here. So that will be 8. You add that place up. Then after that, I have my what? So I have 40 volts. Then here's 3 ohms. And then we have here to be 5 ohms. So with this, I can see that 8 ohms and what? 13 ohms are in parallel. So if I can get the overall equivalent resistance to be equals to. So here they are in parallel. So that will be what? 8 times 13 over. The equivalent resistance for this part will be 8 times 13 times 8 plus 13. Then after that, it's a series of 5 ohms and 3 ohms. So that will be 5 plus 3. And when you do that, you get the answer to be 11, right? You get 11.952. Find the total current or main current in figure 6. So once we know this, the total current, the equivalent resistance, so we can get a simple circuit diagram. Remember, so whereby we have 40 volts. This now we have our equivalent resistance with 11.95 ohms, and that will give us a current to be equals to 40 divided by 11.93. So you see that if you are taking 40 divided by 11 point, so that will be what? Now will be 3 point something. So the answer here will be what? C, right? Determine the voltage across the 4 ohms resistor. So we have 4 ohm resistor here. So to find this, I have to get the current, right? So that current is 3.147. I mean the main current. So to find the voltage across the 4 ohms, I have to get the current passing through the 4 ohms. And that current will be equal to, let's say, I2. So if I enter this current, so we know that this 13 was in parallel with 8 ohms. So we take the 8 ohms over in the sum of what the resistors in parallel. So that will be 8 plus 13 times 3.347. And what do I get? So you can see here the answer. That will give me the what? So that will give me the answer to be somewhere. So I get the answer to be somewhere 1 point something, right? Okay. So when you're 18 plus this, that is just like 8 plus 13, that will be 21, right? So you have 8 over 21 times 3.347. Okay. So we have this as a current. Now when you count now the voltage across the 4 ohms. So voltage across this 4 ohms, we know the current, which is I2 times 4 ohms, which will be what? So the current, which is 8 over 21 times 3.34 times what? 4. Right? So when we have this, you can see here, okay, 8. So if I have 8 times 4, that'll be 32. 32 divided by 21 times 3.34. So 21, that'll be 1 point something. So 1 point something times 3. So the answer here, when you look here, the answer is somewhere 5.14, right? Yes, so we get around this. Now, preamble 11. Use figure 7 to answer question 20 and 21. Okay. So when you look at question, so here should be 114. Okay, same mistake here. 114 and then 115. So when it comes to 100 and then 14, we have to find the equivalent voltage. So to find the equivalent voltage, you can see here, you can use Millman's theorem, which will be the easier method to use here, because we can see that 3.3 kilo ohms and then 1.8 kilo ohms are in series. So we can just simplify that, right? And then after that, it will follow the pattern, Millman's theorem pattern, like so forth. We can now use Millman's theorem in that regard. How do I use a Millman's theorem? So to use a Millman, you know that we have what? Equivalent voltage in series, what? Equivalent resistance. Then we have our terminal A and B. Then I can connect the load resistor, right? Now we are asked to find the equivalent voltage. So to get the equivalent voltage, I know equivalent voltage is going to be equal to equivalent current times equivalent resistance. So for equivalent resistance, it will be what? 1 over the equivalent resistance over the first branch, right? Here, 3.3 kilo ohms and 1.8 kilo are in series. So I can just come here, that will be 1 over 1.8 plus 3.3 kilo, right? 10 to the power 3 plus 1 over, again here will be what? 1 over 4.7 times 8 to the power 3 plus 1 over 5.6 times 8 to the power 3. So when you do all this, equivalent resistance here will give you 1.7 ohms. So with this, I can get the equivalent what? Current. When it comes to the equivalent current, it's going to be close to what? Again, we think about what? Source transformation when it comes to this. So for source transformation, meaning 20 volts in series, what? The sum of 1 plus sum of 1.8 and then 3.3 ohms. So, and then you can see here the terminal here is what? Minus positive. So that will be negative, right? So that will give us negative 1 over, the voltage is 20 over 1.8 plus 3.3 times 8 to the power 3. Then when it comes to here too, you can see here is also negative, minus, also that will be negative current. So I can indicate here as minus the voltage, which is 5 over the resistance 4.7. Then the last one will be what? Positive. To be what? 6 over 5.6 times 10 to the power 3. So we have this, and when you do, you get that current here to be equals to minus 3.94, right? 0.14 amps. So the voltage, equivalent voltage will be equals to minus 3.914 times 1.72 kilo, right? Remember here will be what? Milli, right? So here will be milli, when this, okay, you get there to be this kilo power 3. Okay. So here we 10 raised to the power, this will also be times 10 to the power minus, okay. Here will be milli, alright. Milli, okay. So times 1.72 times 10 to the power 3, which is kilo. So that will give us the answer to be minus 6.662. So that will give us D. Okay. Now, question 115. Calculate the current that flows through the load resistor in figure 7. So once I know the equivalent voltage and the equivalent resistance, I can get the current passing through the load resistor. And how do I get it? By just saying the current will be equals to what? The equivalent voltage over the equivalent resistance plus what? The load resistance. So that will give us minus. So here we can just change the what? Since this is minus, I can just come here, change the polarities here that I have. So we have minus plus. So in that, so once I've done this, I don't have to indicate the negative here. So I can just write 6.662 over the equivalent resistance, which is 1.7 plus 10 ohms. So here I'll be times 10 to the power 3. So that will give us milli. So when you divide this, you get the answer to be 0.56, right? 69. Now, that's how we solve for question 115. We go to question 116. But we have preamble 12, right? Use figure 8 to answer question 116 to 119. A delta connected with its Y equivalent is presented in figure 8. So we have this as our figure 8. Okay. So question 16, what is the resistance of R1? So to find the resistance of R1, you can just even come here, insert this here. Just insert this. So here's my R1, R3, R2. So if I want R1, that would just be equals to what? The product of what? The adjacent delta resistors to R1. So that will be 5 times 30 over the sum of the delta network resistors. So that will be 5 plus 30 plus what? 15. So what do I get here? Here will be what? 150 over, you add, you get 50. So we get here. So the answer here becomes 3B. What is the resistance of R2? For R2, again, it's the product of what? The adjacent delta resistors to R2. That will be what? 5 times 15 over, again, the sum here will be the same, which is 50. So I have 75 over 50. And that will give me 1.5 ohms. So the answer here is A. Now we go to 118. We want R3. So for R3, so when you come to R3, so here again the product of what? The adjacent delta network resistors to R3. So that will be 15 times 30 over, again, 50. So that will give me 0.45 over 50. So this cancels, so we get 9. So the answer here for question 118 is C. The delta network in figure 8 is also called, you can call this a pi network. 120 Thus, theorem said that the current through an element in the circuit is the algebraic sum of the currents through the element if each independent source is acting alone. That is superposition theorem. So that is the end of the questions for the first part of the last year final year examination. So I'll solve the remaining questions in the upcoming video. See you in the next video. Bye bye.